Right, here's part 2 of the Newton's second law of motion, core practical. This is where we're gonna change the independent variable. In the first part, we changed the accelerating force by changing the slotted masses, and we measured how the acceleration changed because of it, and we kept the mass of the system constant. Now, we're going to flip our independent variables. Instead of changing the force, we're going to change the mass and measure how acceleration changes. So again, acceleration is still our dependent variable. Going to keep the accelerating force constant. So I'm going to stick with our 8 lots of 10, our 80 grams of slotted masses. I'll just check that. 1, 2, 3, 4, 5, 6, 7, 8. So there you go. So that accelerating force is going to stay constant. Now, I'm going to keep the mass of the system the same. We're going to change the mass of the system by adding these masses to the cart as we're going through the practical. Okay. Now, before we start though, we want to know our starting mass. So I measured this right at the end of part 1. But let's just check this again. Okay. So this is the mass we are starting with. So 580.7 grams. Don't believe me? Closer. There you go. So 580.7 grams. So almost 0.6 kilograms. So that's our starting mass. Now, what we're going to do, we're going to add, as we're going on, those metal bricks. Right. I think we're ready to go. Okay, so let's get started. So these, by the way, like I said in the previous video, these just stop it running off before I'm ready. Okay. Hence. Okay, so through the hole there, so we've got no friction or minimised friction. 80 grams, that's going to make our accelerating force constant. Okay, we're ready to go for the first one. So this is our first value of mass. Okay, 1.52 meters per second squared. Now I'm going to add that each of these is 250 grams. I can check it on here. That one is. Right, that's just a bit over actually. You might want to write this down. That one is 251.8 grams. There. So that's what I'm adding. That's the mass that I'm now adding. Okay. Good job of measuring that. Right. New acceleration is 0.93 meters per second squared. Okay. Another one. Let's add that one. So this one's a little bit more. So as you can see, it's a good job I'm measuring these. So now I'm going to add 252.3 grams. 8. So 1, 2, 3, 4, 5, 6, 7, 8. Because we have to keep that constant. Okay. Next up. What, new acceleration there? Or 0.83 meters per second squared. Next up. Here's our third rather mass. Should be 250. Let's even a bit more. 253. Next value of mass to be added, 253.8 grams. Slotted masses. One, two, three, 4, 5, 6, 7, 8. There you go. So ready to go with our 3 added masses. Really important that these masses do not interfere with the interrupt card, as you can see. Okay. Ready to go? Next up, next value of acceleration is 0.66 meters per second squared. And finally, last one. Like I said, 2 should be 250 grams. It is indeed 253, so all a bit over these. There you go. Last mass to be added, 253.2 grams. Okay. Right, last one. We got 80 grams. Our control variable. Last one. Last mass to be added. Are you ready? Okay. .57 meters per second squared. Well, there you have it. I think that's 5 data points to be plotted on the graph. Now, we need to be thinking now about how do we get a straight line? How do we get a straight line, and what is going to be the significance of the gradient? Right. There we have it. Newton's second law. Thank you.